Cocoa is a native fruit of Mexico, which can be put to great use. For example, the fruit can be eaten or made into a drink, the shell can be used as an infusion, fertilizer, or animal feed, also to produce other products such as chocolate or butter, leaving as waste the twigs of this fruit. However, in this research we sought to give it a use, which was to obtain charcoal from this biomass. In the experimental part, we started with our biomass obtained from cocoa and the TIO2 precursor, in this case tetrabutoxide. These were subjected to a sol-gel process, then they were subjected to evaporative drying, physical grinding, then heat treatment, and finally the synthesis was obtained. The second part was for photocatalytic evaluation, starting with photocatalysis, then centrifugation, and finally evaluated with a spectrophotometer. In the results, the photocatalytic activity shows the degradation of methylene blue, where all degraded more than pure TiO2, 1% being the best, with 92.37%. Raman and X-ray diffraction were used to check the structure of our synthesis and that it was not affected by carbon, giving us in both cases, the anatase phase, which is the known phase of TiO2. Finally, in reflectance we did not obtain much variation in the energy gap, 3.2 eV, characteristic of the anatase phase. In conclusion, TiO2/AC, 1%, presented the best degradation of methylene blue, which compared to TiO2 represents an increase of 14.77%. The use of this biomass not only improves the degradation of the pollutant, but also contributes to the circular economy.